Okay, 3.1, law of sines. Why or when would we use law of sines? But it's not a right triangle. If it is a right triangle, we use SOHCAHTOA, right? We use SO, CA, and TOA to solve right triangles. Law of sines is when it's not a right triangle. Now, there was a difference between law of sines and law of cosines. We're going to look at law of cosines tomorrow. Law of sines is when you have two of the same letter. So if you've got both A's given to you, you can use law of sines. Remember, angle A and side A are always across from each other. Okay, angle B and side B are always across from each other, and same with the two C's. Okay, they have to be across from each other. So if you've got one complete fraction, A over A, B over B, C over C, you could use law of sines. And I like this first one because I like to put the angles on top and I like to put the little letters on the bottom. So that's just how I do it. But again, you can see these over here, they switched it around, and that's fine too, as long as you switch all of them around. All right, so let's look at example one. They'll go pretty quick because law of sines is just a proportion. We cross multiply and we're done. So we have C given to us. We have B given to us, so big B and big C, and we have little b given to us. So we need to make a fraction out of the b's first. So sine 28.7 over 27.4. That would be b over b. That would be one complete fraction. We need to find, if we're going to use our proportion, we're going to need to find little c because they gave us angle C. Sine of 102.3 over little c. So we would just get that part. I need to see this part. That's angle C, and you have little c underneath. I need to see your proportions. From there, you can type it in your calculator, but I need to see this part. So the two that are numbers that are diagonals are those two. So I'm going to do those two first. Sine 102.3 times 27.4, and I would encourage you to put these in your calculator and make sure you're getting the same answers. You don't want to think you're doing it right when really you're doing it wrong, and make sure you're in degree mode now because we're using degree numbers again. So we're multiplying those two, and we're dividing by the one that's next to little c, which would be sine 28.7. You're going to end up with 55.7 for your little c. So that's one answer. It does say solve the triangle. So that means we got to find both A's also. Now the nice thing is when you're given two angles, when you've got two angles given to you, like you see here, you can find your third angle simply by taking those two and subtracting them from 180. So you could take 180 in your calculator minus 102.3 minus 28.7, and you'll get 49 degrees for angle A. So that gives us all three angles now. And now we can also set up another proportion where you'll have sine of 49, which is sine of A, over little a, which we're trying to find. Angle A over little a. And I would use the original one that they gave us right here as my second one. I don't want to take any chances that I messed up my answer on the first one. So I would use the ones they gave me already. So I would do sine of 28.7 over 27.4. And if you multiply the diagonals that are numbers, which would be the sine of 49 times the 27.4, so sine 49 times 27.4, we're going to divide that answer by the sine of 28.7. Get 43.1 when you get your little a. 43.1. Make sure your triangle makes sense. Your biggest angle should be across from your biggest side. Biggest angle C, biggest side is little c. Good, that works. Your smallest angle is 28.7. So your smallest side should be 27.4, which it is. So that one does work, it makes sense. And then most importantly, you're going to need to be able to apply it to problems. Now, they may not give you a picture. You might just get a problem. You got to be able to draw it. It's telling you that the pole tilts toward the sun at an 8-degree angle from the vertical. So that means our sun is over here because the shadow's down here on the bottom. And the pole is tilting 8 degrees away from being straight up and down like that. It's 8 degrees away towards the sun. So let's see what pieces we have. We've got angle A. They're asking us to find out how tall the pole is. So all we need to solve for is little a. We don't need to solve the whole triangle. We just need little a. They're giving us big A, so we have that, 43 degrees. So I know I'm going to need to put sine of 43 over little a. That's going to be 1 fraction. Now, the other pieces they gave me little c down here at 22. So I'm going to probably need to get big C because I need both C's. So looking at it, I've got 43 in this angle A. This angle B is also given. It gives me 90 and it gives me 8. So this has to be 98. So I can just find angle C up here simply by doing 180 minus 98 minus 43. C is going to be, let's see what that is, 180 minus 98 minus 43, 39 degrees. So there's your angle C, 39. So I can put the sine of 39 up here. And you can multiply, again, your diagonals that are numbers first. Sine of 43 times 22. Sine 43 times 22. Get that answer and then divide it by the sine of 39. 23.8 is your little a. No, 23.8 feet. So that makes sense because it better be more than 22. 22 was across from a 39-degree angle, and 43 degrees is bigger. So your side better be a little bigger than 22, and it is 23.8. So that does work. So that's being able to apply the law of sines. Now here's where it's a little bit trickier than chapter 9 of our geometry book. Actually, this picture that we started with, I got from chapter 9 of your journal. That's theorem 9.9 in your journal. That was your law of sines. I just snipped it right out of there and put it right on here. Now, when you get to here, though, this next part, this is actually in your book as well. It's in your new trig book. It's called the ambiguous case. It's because there could be different solutions when you've got this setup. When you've got two sides in an angle that's not in between them. Because if it's SAS, you can't even use law of sines. You have to use law of cosines anyways. But if you've got two sides and an angle, you can use law of sines. It's just there's different things that might happen. You might have no solutions. There's two choices there where you've got SSA that there's no answer. And those are going to be easy to find because you're going to go to your calculator and it's going to say error. It's not going to work. So then automatically, okay, no solution. But make sure you know how to do the calculator, because what if you get error when there really is no error? So you got to be careful on that. Make sure you know how to do the calculator. There's going to be ones that have one solution. Okay, those are not going to be hard to find because they're going to work. You're going to multiply your diagonals and divide to get your answer. And that's going to come out. It's going to be nice. And it'll tell you these are when A is acute. Okay, when A is obtuse, it's going to be nice because A is obtuse. You're either going to have one answer or it's not going to work. And it just won't work. It'll be error in your calculator. So you know that obtuse is not bad. It's just when it's acute, there is a scenario where you might have two solutions. You might have two answers. And that's if your side A is between the height and your side B. If that happens, then A could be, you could make this A over here, or you could make this A on this side. And so you could have an obtuse angle down here, or you could have an acute angle down here. Just depends on what we get. So let's take a look at some of the cases, and we'll see when the one with 2 pops up. I'll show you. The other ones are you're gonna be easy to see. That one with 2 is a little tricky. So let's look at example 3 here. You've got A, and you've got B, and you've got big A. So I know that I'm going to need sine of 42 over 22. And I'm going to need to find an angle B, so I'm going to need to put an inverse. Remember, inverse to find angles. You need that -1 if you're finding an angle. And 12 goes on the bottom. Now look at this case. You've got A is greater than B, and A is acute. A is acute. A is greater than B. You're only going to get one answer here. So one answer that you get is going to be the answer that's it. It's going to come out even, and you're going to be nice and good. Okay, so let's look at the one answer we need. We've already got the proportion. So we just multiply the two their numbers, sine of 42 times the 12, and then divide that by the 22. You're going to get a 0 point something, 0.3650 when you round it off, equals inverse sine of B. This is the decimal because it has to be a 0 point something, because we know sine is 1 or less from our unit circle. We know sine has to be 1 or less because it'll never go above 1 or lower than -1 on our curve. So we need to put that into the inverse. So hit second function sine 0.3650, and you get 21.4 degrees. So angle B is 21.4 degrees. Once you've got angle B, that opens up getting C's now, because you now have angle A and angle B, and now you can get angle C by subtracting those from 180. So angle C, you're going to have 180 minus 42 minus 21.4. Because angle A up here was 42, and then angle B we just found was 21.4. So 180 minus 42 minus 21.4. You get 116.6 for C. So that's your angle C. So you're going to be able to use that in your law of sines. Sine of 116.6 over little c. We need to find little c. The original fraction they gave us was right here, sine of 42 over 22. Use that one, because that one you know is true because of what they gave you in the problem. So sine of 42 over 22. So again, multiply the two that are numbers. Sine of 116.6 times the 22 divided by the sine of 42. And you get 29.4 for little c. So you have all 6 pieces now. And that's the biggest side. C is the biggest angle, and it's across from the biggest side. Those are together. Biggest angle, biggest side, right there. And then your smallest angle was 21.4, so B is your smallest side, and it is, it's 12. So it does make sense. When you get to number 4, again, you have, this time you've got A is less than B, and A is acute. A is less than B, and A is acute. Okay, well, A is less than B right here because A is less than the height, and B is longer than the height. So this could have no solutions. If it does have no solutions, it'll say error on our calculator. So we don't have to worry about it. If it's no solutions, it'll say it. Here, A is equaling H. That's going to be a right triangle, so we don't have to worry about that. That has one answer. And we have 2 answers when A is less than B, but it's greater than the height. So let's see what we have on this one. We have sine of 85 over 15. That's your A over your A. And we need let angle B. So inverse sine of angle B, we want the angle, we got to use this inverse. And little b is 25. So sine 85 times 25. Get that answer, divide it by 15. And you get 1.6603 equals inverse sine of B. This is the decimal I'm supposed to plug into my inverse sine. So what do you think is going to happen if I plug in an inverse sine of 1.6603? That's where you're going to see it's going to be an error. It can't work. Domain error, because sine will never be more than 1. Remember that you hit a sine button, you're never going to get something more than 1. You hit the sine of any angle, it's either a 0 point something or it's a 1. That's it. It won't go higher than 1. So this one definitely has no solution. There's no triangle that can be drawn. No triangle that can be drawn with those two sides in that angle. Can't make a triangle out of it. And if you look at number 5, you're going to have A is less than B again. A is less than B, and A is acute, very acute. It's only 20.5. So we would put sine of 20.5 over 12. That's your A over your A. Inverse sine of B, we want to get angle B over 31. So if I multiply those diagonals, the ones that I have, sine of 20.5 times the diagonal of 31, and then divide that by 12, you will get a 0 point something. So there is a solution, 9047, and you get to the inverse sine of B. So you got to take this decimal and you got to plug it in to B for the inverse sine. So if I do that, inverse sine of 0.9047, I get 64.8 degrees when I round it off. 64.8 degrees. So that means that if I was to plug into my calculator sine of 64.8, I'm going to get that 0.9047 back. Okay, if I plug that in. The sine of this angle is that decimal. But what I want to show you is kind of what we've been looking at with our unit circle. Now I want to illustrate it with a 60-degree angle just because it might be easier. Okay, so the sine of 60. If you don't have your calculator, then look at it, but do it in your calculator if you have it. Sine of 60, you get 0.866. Sine of 60, here, let me write that up here. Sine 60, 0.866. Okay, now I want to put in sine of 120. Okay, so sine 120. Different angle, right? 160, one's 120. When I hit equals, I get 0.866 again. I get 0.866. Both of these angles have the same sine value. So that's what I was trying to show you down here. Not only does this 64.8 degrees have 0.9047, but there's another angle that has 0.9047. And it's your reflex angle. It's the angle you would get if you subtracted from 180. 180 minus 64.8. Okay, so 180 minus 64.8, and you get 115.2. If you take the sine of this angle, sine of 64.8, it's going to be the same value as the sine of 115.2. They're going to have the same answer, just like the 60 and the 120 did. So not only could angle B be the 64.8, but it also could be the 115.2. There's two separate triangles that we could draw. Now let me show you why these two are like this. Okay, so 60 degrees. Let's say, if you remember, we have our unit circle, right? It goes around like this. Okay, our unit circle, you guys had your project. Okay, if I drew a 60-degree angle in the unit circle, that means this would be 60 degrees. And I would drop down and make a triangle. And my y value, since the hypotenuse was a 1, because it's a unit circle, the y value was my sine value. Okay, that was y over 1, which is just y, opposite over hypotenuse. Well, think about what 120 looks like. 120 starts here, goes past 90, and goes 30 degrees more, so it ends up going about up to here. That's going to be 120. But when we draw in our right triangle, it's the identical triangle. And y is still positive because this is above the x-axis. So this is like another 60-degree angle right there because we had the 120 and we had 60 degrees to get to 180. So you're an identical triangle. Both sine of 60 and sine of 120 would actually be the same triangle, just a reflection of each other. So that's why those two are the same. That's why these two are the same over here, because we subtracted from 180. One's in quadrant 1, one's in quadrant 2. Calculator likes to give you the one in quadrant 1. That's what they're going to give you. So if I just went with quadrant 1 only, since I have B, I could start with or I could actually find angle C first, because now I have A and B. So my angle C would be 180 minus the 64.8 minus the 20.5 that angle A was. Okay, we had 20.5 for A right there. So if we subtract those, 180 minus 64.8 minus 20.5, and you get 94.7 for C. If you had gone with B as the obtuse angle, let's say your triangle had B as an obtuse angle of 115, then you'd have to find C as 180 minus 115.2 minus the 64.8. No, not 64.8, 20.5, sorry. Minus 20.5. So this time your angle C would not be obtuse. It would be an acute angle. 180 minus 115.2 minus 20.5. So you get 44.3 degrees for your C. And then you can take both of those and you can find little c now. Now that you've got big C angle, so sine of 97 or 94.7, you want to find little c. They gave us angle A of 20.5, and they gave us little a, which was 12. So this first fraction is what I'm using right there. So let's see. Sine of 20.5 over 12. So if I was to multiply the diagonals, again, sine of 94.7 times 12 is the diagonal. Take that answer, divide it by sine of 20.5. And you're going to get 34.1 for little c. And it makes sense because in this triangle, C is your biggest angle, so little c is your biggest side. In this first triangle, on this side over here, this first triangle, you'd have C is your biggest side and little c is your biggest angle. If you use this triangle on this side, now you're doing the sine of 44.3 over little c, and you're doing sine of 20.5 over 12. From our A over A, you're going to do sine of 44.3 times 12. We're going to divide that by the sine of 20.5. And you get 23.9. Where B was bigger this time. B was 31. So B was your biggest angle of 115.2, and B was your biggest side of 31. C was a smaller angle, and it was a smaller side. So that would be your two separate triangles. You had one on each side here. So like I said, you're not going to have to really know. You're going to just need to give me one of them. So you're probably going to find the ones in the first quadrant anyways. But if you see the back of the book when you're doing your homework and you see that there's two answers, you'll know it's because your angle B was acute, and you could subtract it from 180. You could subtract it from 180 to get your other angle that would have the same sine value in quadrant 2. So that's how that one worked. All right, let's look at the area one. We actually learned this area formula. This is another piece that I snipped from your journal. If you don't know the base and the height, then you could use this new formula. 1/2 times the two sides times the included angle, the angle between them. All of them are the same formula. You got the two sides and an angle between those two sides. You'd have these two sides and you'd have the angle between those two sides. But our original formula always works. Base times height over 2. If they give you the base and the height, that's what you'd use. If they wanted the area of a right triangle, then you just use this base and height, because your two legs are your base and your height. There's a right angle there. If it's a right angle, it's a base and a height. But if it's not a right triangle and it's some kind of oblique triangle, you can use this new formula. So it says find the area of a triangular lot has two sides. So your area, you got the 1/2, you got the two sides, 52 and 90, and you have the included angle of 102. So sine of 102. You're going to multiply all that together. When you do that, you're going to get about 2,289 square meters. You will have at least 2 area problems on the test. Those are that easy. It goes right in. If they give you the two sides and the included angle, then boom, you can put it right in your calculator. 0.5 times 52 times 90 times the sine of 102. If you put that right in your calculator, you'll get 2289 when you round it off to the whole number. So that one shouldn't be hard. And if, like I said, keep in mind that if you have a right triangle, you are going to use that formula because your two legs are your base and your height are your two legs. Okay, so just keep that in mind. All right, last one. Probably the most important because the test is full of some word problems, full of application. Can you apply what we've learned? Can you take your trig functions, can you take law of sines, can you take SOHCAHTOA, law of cosines, and put it to work on a problem? In this problem, we have a boat race. Okay, the boats all start at A. They go from A to B. Now they're telling you that they're going at a 52-degree angle from south. That's what this direction's right here. From south, you're going 52 degrees towards the west. Okay, and then they're gonna get to B, which is probably like marked with a buoy or something, and they're gonna make a turn down to point C. Now that turn, they're telling you, is from the south. It's 40 degrees towards the east. South 40 degrees east. And then it says from there, they're going to go straight back to point A. And they're telling you that C is due south of A, so it means you went straight north to get home. Because it says point lead lies 8 kilometers directly south of A. So this line from A to C is actually a north-south line because it's vertical. It's exactly vertical. It says approximate the total distance of the race course. Total distance means we want the perimeter. What are the boats actually going to be, how far are they actually going in the whole race? Total distance from A to B, from B to C, and from C back to A. We know one of those sides is 8. We need to get little a, and we need to get little c. But to do that, we're going to need more than what we've got. We're going to need the two angles. We're going to need angles B and C. So do I know either one of them right now? A or C, or B or C? Can I find either one? Which one would you want to find? It would be nice if we could find B, but we can't. We could find C, however, because this line is north-south. This line is north-south. This angle and this angle have a special name. And this line has a special name right here. It's called a transversal line. When you cut between two, you cut across two lines, two parallel lines in this case, it's called a transversal line. And does anybody remember what these two angles are called? Because they're in between the two lines. They're in the interior of the two lines. And they alternate sides of the transversal. alternate interior angles. They're always equal, so this is also 40. So we got 40 degrees for C. Now we can find B, because to get B, we just take 180 minus 52 minus 40. You're going to get 88 degrees. So this angle is 88. Now we have all three angles. Now we can set up our sides. We can set up our two sides that we want to get. So I'm going to have to use the sine of 88 over 8. That's in both. That's the one that I have both of. So I have both B's. So sine 88 over 8. If I want to go alphabetical, I'll do sine of 52 over little a.
Really? Hey. Hey. Yes, she is. Okay, all right. Nikki, balance way. You get to go.
Okay. So we got our first one here. Let's put the second one up. We need sine of 88 over 8 again. This time we're going to do sine of 40. 40 is the angle across from C. So we're going to multiply our diagonals there, the two that are numbers. Those two, sine of 52 over 8. Sine of 52 times 8, and then we're going to divide by the sine of 88. That's going to give us 6.3 kilometers is side A. So when they were doing side A, across from A was 6.3, across from the 52 degrees, 6.3 kilometers. If we solve for C over there, we're going to do sine of 40 times the 8, and we're going to divide that by the sine of 88, and you get 5.1 kilometers for C. So right next to C up here, we'll put 5.1 km. So they want the total course, total distance. So our course has a side of 8, a side of 6.3, and a side of 5.1. You put those three together, and you're going to get 19.4 kilometers is your race course. That's how far the boats are going to travel. So that's an application problem. Using law of sines, you had to remember alternate interior angles to get there. But after that, it was just getting law of sines. So that is it.